Hello students, we will go with the third type of problem in convolution. So the question is, find the L inverse of 1 upon s minus 1 into s square plus 1 using convolution theorem. As I have already told, when a convolution theorem, if they say, means you are required with two functions, that is f of s and g of s. So if you observe in the denominator you are having two brackets, so try to split this into two functions as 1 upon s minus 1 and another one 1 upon s square plus 1. Denote that as f of s and g of s. Once we get f of s, find what is f of t. What is f of t? It is L inverse of f of s. That is L inverse of 1 upon s minus 1. So L inverse of 1 upon s minus a, it is e raised to at. Now a is how much? 1. So e raised to t. Once you get f of t, find what is f of u. Just replace t by u. That is e raised to u. Next, here you have got g of s. Now find g of t. How to find g of t? It is L inverse of g of s. What is g of s? 1 upon s square plus 1. So whose L inverse it is? 1 upon s square plus a square. It is sin at upon a. Now what is a? 1. So sin t. You have got g of t. Find for g of t minus u. That is sin of t minus u. Hence now we will consider for the convolution theorem once you have f of u and g of t minus u. Now we will consider for convolution theorem stated as L inverse of f of s into g of s is equals to integral u equals to 0 to t f of u into g of t minus u du. What is f of u? It is e raised to u. G of t minus u is sin of t minus u. Now if you see, it is a product of two functions in which one is the exponential function and another one is the trigonometric function, that is sine. And I have already told you all in my repeated videos, I have always told that if you get a product of an exponential function and a sine function, do not go to apply Bernoulli's rule or the integration by parts. We have direct result. What is that result is? Integration of e raised to ax into sin bx plus c is equals to e raised to x upon a square plus b square into a sin bx plus c minus b cos bx plus c. This is the standard result which you have to use whenever you have been given this type of problem. So now compare. Here in place, this is with respect to u. This is the integration with respect to x. So in place of x it is u. So x is nothing but u. Now what is your a? Coefficient of x in e to the power is your a. Then here coefficient of u in e to the power is your a, that is 1. Then what is b? b is the coefficient of x in angle, that is sine of. So b will be the coefficient of u in sine of. What is the coefficient here? If you compare, it is minus 1. X is your u, and what will be your c then? C will be your t. Okay. So now substitute e raised to 1u upon 1 square plus minus 1 the square. 1 into sine. Here b is how much? Minus 1. X is u. So minus u plus t, because c is t. Minus b is how much? Minus 1. Cos of b is minus 1 into u plus t. So this is what you will get. So limits ranging from u equals to 0 to t. Simplify before you substitute the limits. So e raised to u as it is. 1 square is 1. Minus 1 the square, it is plus 1. Plus 1 plus 1, it will become 2. Sine of minus u plus t can be written as t minus u. Minus of minus, it is plus. Cos of t minus u. This now limits we have to substitute. Upper limit is u. So lower limit is 0. What's the upper limit? T. So here e raised to t upon 2. Okay. T minus t is 0. t minus t is 0. So sin 0 cos 0 here. Sin 0 plus cos 0. This is upper limit minus lower limit. Lower limit is 0. E raised to 0 upon 2. Sin of t minus 0 is t. Cos of t minus 0 is t. So cos t. Hence e raised to t. Sin 0 is 0. Cos 0 is 1. 1 plus 0 is 1. 1 into e raised to t by 2, it is e raised to t by 2. Then e raised to 0 is 1. 1 upon 2 into sin t plus cos t is remaining. Removing 1 by 2 common from both, you are remained with e raised to t minus sin t minus cos t. This is the solution for the given L inverse by convolution theorem. Thank you.